Check 1 2 3. Off त अफ गरे अफ गर्दैन त्यो अन गर्नु न छैन चल्दैन सेटिङ असिङ कलर प्यानल आउँछ छ कि चेन्ज हेर्दी रोबिन कति राख्ने हो कति राख्ने 1080 त छैन 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 1024 तर पछि स्लाइड देखाउन गाह्रो चिप चेन्ज चेक चल्दैन चेक मका लागि छु मका चाहिँ रिजल्ट छ मका
Hello, hello, check. One, two, three, four. Hello.
श्रीराम सर कस्तो मिलेछ म खसाल्नु आज खसाल्नु
Hello, check. One, two, three, four. Hello, check. Hello, check. One, two, three, four. Hello. Hello, check. One, two, three, four. Hello, check, check.
As we are about to begin, I would like to request everyone to be in Hall 1.
दुईटा मात्रै छ त सिजन 4 को कति सिजन 4 मा थियो हैन हैन त्यो चेन्ज भयो के एउटा हल 2 बाट चेन्ज भएको छ
हैन यहाँ छ हल 2 हैन नि त हल 2 मा हामीलाई चाहिने
हल 2 को यो चेन्ज गरे एक्सचेन्ज गरेको के यो यो तल चाहिँ प्रेजेन्टेसन दिन्छ हैन माइक अफ गर न
Hello. As we are about to begin, I would like to request all of you to switch your mobile in silent mode. And I would also like to inform that this keynote speech is live in YouTube via Workers' Voice and also in Hall 2. With an objective to promote the reconstruction campaign after the 2015 Gorkha earthquake, with an objective to bring national and international researchers on a common ground to widen the horizon in research findings and development activities in the field of earthquake engineering and post-disaster reconstruction planning. We are here today. Namaste and a very good morning from Regina, your MC of the day. Respected keynote speakers, principal of Khopo Engineering College, as well as Khopo College of Engineering, vice principals duo of respective colleges, member of scientific committee, session chairs, distinguished guests, paper presenters, participants, journalists, and volunteers. I'm delighted to welcome you all to our second day of Second International Conference 2019. I hope our international presenters and participants are exploring Bhaktapur, the city of living museum. I must say, it would be a very good start of the day with a keynote address by Professor Dr. Premnath Maske sir. Professor Dr. Premnath Maske is MSc graduate with honors in civil and industrial structure from Patrice Lumumba People's Friendship University, Moscow, and the first PhD in engineering from Tribhuvan University, Nepal. He started his career as a faculty in civil engineering at the Central Campus, Pulchok, Institute of Engineering in 1975. During his professional career, at IOE, he was involved in the initiation, development, and implementation of various academic programs in engineering. As the chairman of Civil Engineering Subject Committee, he was responsible for development and approval of the first curriculum for Bachelor in Civil Engineering. Besides teaching, he has extensive experience in the academic management of institutional program as the first program coordinator of MSc in Structural Engineering. He was the director of the Center for Applied Research and Development, under the initiation of which the PhD level program in various engineering disciplines was formally introduced at IOE. He has been involved in various research activities related with earthquake engineering, seismic risk analysis, and disaster risk mitigation of cultural heritage sites in collaboration with reputed international universities. He is the main scriptwriter of Disaster Risk Management Plan for the historic city of Patan, Nepal, prepared by the Research Center for Disaster Mitigation of Urban Cultural Heritage, Richumikan University, Kyoto, Japan, and Institute of Engineering, Tribhuvan University. He has currently been engaged in the revision of Nepal Building Code NBC 105 1994 as a national structural engineer as well as a team leader. Professor Maske has been recognized for his contribution to education in Nepal by the government of Nepal, being awarded Education Day Medal. Ladies and gentlemen, may I take this opportunity to invite Professor Dr. Premnath Maske to deliver the keynote address on masonry structures in the post-earthquake reconstruction.
Pointer चाहिँ तल होइन नेक्स्ट यो
चाहिँ previous. Thank you. Thank you, Regina. Very good morning, ladies and gentlemen. So, first of all, I would like to thank the organizers for giving me this valuable opportunity to speak on the pertinent issue with the reconstruction, and I have taken myself the liberty to name it as masonry structures in the post-earthquake reconstruction for two reasons. Because we cannot avoid masonry structures, whatever may be the situation with the present modern materials in the world. We being poor country with a poor civilization, and we love masonry not because we love it for other reasons than because we cannot go for other materials apart from masonry structures starting from the beginning actually. And also another thing very important you understand before we commemorate this event which occurred 4 years ago actually. Just day before yesterday there were 3 tremors which are supposed to be aftershocks following the 2015 Gorkha earthquake April 25 actually. So salute to that prelude whatever it is, and we should be prepared. And so mostly I'll be talking about little bit about what is happening with the reconstruction of structures mostly related with masonry. So now we know that Kathmandu Valley and Nepal also lies in a very highly seismic risk zone. That is one point. Another point is this is the country, this is the valley, Kathmandu Valley particularly, which accommodates most of the masonry structures. So these are two interrelated things, and although we know that masonry structure is very brittle and not very suitable for earthquake resistance, etc., but let's not forget that we do have basically low-rise buildings, low-span buildings, etc., for which masonry structure may not be that bad. And probably that is the reason also that our ancestors started with masonry structures like in other parts of the world. And but it is true that at a time they used the best materials available with best technology used, otherwise there was no other materials at that time. So now first of all let us talk about the high risk of seismicity, the Kathmandu Valley I mean. So this is actually attributed to the seismotectonic activities so related with the Himalayan region, which is young mountain, and also the subsurface soil condition of Kathmandu Valley. So we do have a very soft and deep soft soils. So due to which every time whenever there is a large earthquake in Nepal, not necessarily in the vicinity of Kathmandu Valley, always the maximum effect is in Kathmandu. So we can recall what happened during 1934, what happened during 1933, and also back if we go starting from 1255. And recently we have witnessed in 2015, also 2011 during this what you call Sikkim earthquake, also in 1988 during Udaipur earthquake. All the time the damages were in Kathmandu maximum. So 2015, although it is not the maximum earthquake, I must say, so having a very limited value of peak ground acceleration, although it is very near to Kathmandu at Barpak, 81 kilometers away. So but the damages were extensive actually, and there are other reasons also which we will be talking anyway. So this is the seismicity of the Kathmandu Valley, and you know that April 25 earthquake, the main shock during Gorkha earthquake, was moment magnitude 7.8, which was followed by numerous aftershocks, one of them being very large, that is in Dolakha on let us say in the May itself, May 12 of 7.4 moment magnitude. Now since then there have been number of aftershocks, let us say of magnitude larger or equal to 4 has been more than 500 actually. So 512 exactly speaking of aftershocks with magnitude ML larger than or equal to 4 till April 11, day before yesterday, when 2 aftershocks in the morning of 5.2 and 4.3, and also in the afternoon of let's say some 3.8 something like that. So this may continue again, I don't know, and that is how we have to live up with the seismicity of this valley and also other parts of Kathmandu. And in the meantime, let us also talk about some masonry structures in Nepal. So Kathmandu Valley is extensively known for extensive use of unreinforced brick masonry. So when we talk about masonry, it may have different meaning, but for the Kathmandu Valley is related with brick masonry basically. So otherwise we could talk also about, let us say, stone masonry or concrete hollow block masonry, confined masonry, and so on and so forth. But related with Kathmandu Valley, it is mainly unreinforced brick masonry. So now Kathmandu Valley is accommodating many historical and monumental structures like various temples, viharas, palaces, dwelling houses, traditional houses in unreinforced brick masonry, that too in mud mortar, which is little bit odd for our international delegates, and that represent the traditional structures of Nepal. So all these historical and monumental structures, including traditional dwelling houses, carries a very heritage value, and that's why conservation that becomes very important, and that is not only our interest, that is also the duty of national and international society. So most of these buildings or most of these masonry structures were built in Kathmandu during the medieval period of Nepal, and so in view of this heritage value carried by these structures, actually UNESCO has enlisted Kathmandu World Heritage Site with 7 monument zones with different these structures actually. So now if we go a little bit back to the history of masonry structures, not only in Nepal, so masonry structures probably have been the first type of construction which has been extensively used in the world, and that has been common type of construction for a very long time in the world. Like history of masonry dates back to, let us say, Egyptian pyramids, or let's say the Colosseum of Rome, the Taj Mahal, the Great Wall of China, if we name few of them, so which are known to us for a long time. And through civilization, construction in masonry has been the choice for its beauty, versatility, and durability, and this was found resistant to fire, earthquakes, and sound. So all of us, we may not agree that it is earthquake resistant, and I should agree with that also, but at that time, because due to limited availability of materials, it was also needed to be used as earthquake resistant. So evidently masonry structures have withstood the normal wear and tear for a long time, for centuries, and that is why it still is popular in developing countries like Nepal. Now this is some steps, some notes on the historical development in masonry, like it was being the simplest of the building techniques. So masons stack pieces of materials like bricks, stones, or concrete blocks, etc., over the top of one another to make walls, etc., etc. That is how it started, and this construction began as low walls of stones, or let us say caked mud, sun-dried bricks, and other things are the development. I'll just skip all those things. So later mud mortar was replaced by limestone mortar, lime mortar, etc. And important to note actually is, like in Mesopotamia, palaces and temples were built of stone and sun-dried bricks even in 4000 before Christ. And the Egyptians erected their temples and pyramids of stones by 3000 before Christ. By 300 before Christ, Greeks perfected their temples of limestone and marbles, and Romans made the first large-scale use of masonry arches and roof walls in their basilica, baths, and aqueducts like that. So this is some historical development points actually. Now in case of, I'm coming back to again Nepal, Kathmandu basically. So we talk about traditional masonry structures, which are, as I said, unreinforced brick masonry. So main structural system actually is unreinforced brick masonry walls with mud mortar. Now we know that many people, many colleagues, many friends have got not very good impression about the brick masonry, and that too with mud mortar. Like there used to be my very good friend, structural engineer, who is now working in United States of America. We started our profession almost at the same time, has very unfortunately given one article in the local daily paper saying that all the masonry structures, including all the heritage structures, monumental structures, historic structures, should be demolished. And this was too much for us, I think. And I did have a fight with him also that it is not United States of America. This is Nepal. And we do have a couple of stories of buildings, including heritage structures. And you are talking about Manhattan having, 100 stories building, etc., etc. Definitely we are not going to build it. We also know that this unreinforced brick masonry has got limited strength against earthquake. They are very brittle, agreed, no problem. And as an engineer, we are also advocating the new materials, stronger materials, durable materials. There is also no doubt about that. But our culture lies in these masonry structures, and we are not going to build 18-story building, 20-story building with these masonries and with mud mortar, etc. And by saying that, at least I am not happy with his statement. It says that he has closed the door to think about these use of them, resource on them, etc. So that's why we are lagging much more behind also. For unreinforced brick masonry or masonry structures, developed countries has already stopped because that was not their demand, unless it is, let's say, some parts of Europe like Italy, Portugal, Spain, etc., where still they are doing a lot of researches in this masonry, etc. But in our case, it is inevitable because we do have a lot of heritage structures, monumental structures, etc., which represent our culture, our civilization, and we have to retain them. That is the main thing, and that's why so nothing wrong if the new constructions are being taken place with new materials like concrete, steel, or even let's say polymers or FRP, etc., etc. There is nothing wrong with them. But the conservation of old materials according to conservation principle, etc., to retain also is our job. Anyway, so I'm coming back to traditional masonry structure, and particularly I want to emphasize on their behavior, their characteristic in relation with earthquake resistance. Like main structural system, although being unreinforced brick masonry walls in mud mortar, about mud mortar also now, it is like I said, people have stopped, closed the door for further research, etc. That is the problem. Otherwise, now we came to know that mud mortar is not the mortar made of just the soil, whatever is available from the debris, etc. That is not true. Basically, mud mortar should be made where used were used to made of soils which comprises of clay content less than 20%. So there might be more silt, there might be more sand, etc. No matter. But if it is more than 20% of clay, it gives shrinkage, high shrinkage, and very low strength. So if we do that, then we will get a better mortar for masonry. So for your kind information, I would like just to inform that we are just carrying out this reconstruction of Kastamandap these days, and there the requirement is we have to make the mud mortar, and I gave this ratio, etc. thing, and we tested it. And if you are interested, you can visit that Kastamandap Reconstruction Committee office at Hanmandoka. You are free to go there and you can find it. Some tests are being carried out still. And people are wondering, I am not praising it. I was puzzled to find that mortar so strong that people are asking whether you have added some cement or something like that. It is not true. And another fact is, if we add cement for stabilizing purposes, it is not giving a very pretty result. As we know, my colleague Flavia is there. We tested those things, and I gave just therefore yesterday that presentation in our workshop. So it is not very good for mortar if we are going to stabilize with cement, but for other purposes it may be better. Now another factor with this traditional structure, masonry structure, is timber floor. Timber is extensively used right from the beginning. As I told you, best of the materials and best of the technology were used at the time, because most of these things were strictly adhered to the standard, although it is not written and although we didn't have any codes as such. But artisans were there, craftsmen were there who would follow strictly to the rule, which were actually learned from generation to generation by mistake actually. So another factor, main thing actually, is regular geometry. They are symmetrical in most cases, and basic concept of load transfer, load path, and also earthquake resistant design was well understood. So that's why, so it was, although with limited strength, limited earthquake resistance, this has been extensively used, and evidently many of them are still standing. Now I'll come to that a little bit later. Then why 2015, although I label that as not a very large earthquake, affected, resulted into large damages. I will come to that a little bit later. So there are some these photographs of three Darbar squares of Kathmandu Valley, which are very prominent for their architecture, art, and these masonry structures, like Darbar Square of Bhaktapur, like there is 5 stories temples, and also this Kashi Vishwanath temple, Bhairavnath, the later one actually. So as you see this one, this is prominent in relation to earthquake resistance. So this is in the same square, and according to one research I carried out, so I found that the soil sediment is very soft here, very soft. So that's why the amplification of earthquake ground motion obviously would be too large. Probably that is one of the reasons that that high plinth was made here. And now, like this high plinth, which is about 8 meter, or exposed foundation you can call it actually. So above that we do have this temple of about 21 meter height. Now during 1934 earthquake, evidently, so this temple, which is very rigid compared to that, was collapsed to the ground itself, no traces itself, whereas in this temple only the topmost story was damaged. So that shows something, although the planning also plays a role, but basically this high plinth of 8 meter actually, which is very rigid because these are all brickwork, so it has got high shear of velocity, so and is responsible for reducing the amplification factor from the ground motion. So that's why it was saved. In this case it was not so, the plinth was almost none, and that's why this wall become your collapse actually. So this is another Darbar Square in Kathmandu actually. So as you see, so also another high plinth, which is Mazudega there, it is there, this one. This also during this 2015 earthquake, it got collapsed up to the plinth, but nothing happened in the plinth. So it is under reconstruction again. And next is this Patan Darbar Square. So this is another example I wanted to show actually. This is your Patan Darbar, and this is Devutalogic Palace we call. So this one, now in 1934 also it was collapsed to the ground actually, but not in 2015. And that is another reason. What is the reason behind the damages of these structures? Like this didn't get much damages in 2015 because it is recently renovated. Same case with 55 Windows Palace actually, which I showed here. This is 55 Windows Palace here. This one, this also not, I mean it survived this 2015 earthquake because it was also recently renovated. Like in 2006 we finished renovating it without any traces of retrofitting, but we are just following the old detailing about. So that shows that if there is new materials and if it is being renovated or replaced with new material, etc., it didn't get any damage. So that is not true for all the earthquakes. At least for 2015 earthquakes that was true. So now main features I want to say about these traditional masonry structures, or basically masonry structures of these Kathmandu Valley buildings, etc. Like they are symmetrical because it gives mass and rigidity, regular mass and regular rigidity distribution. Triple wall system in the dwelling houses, and limited openings were there, but they are also provided with double timber framing, which is very good. So timber and timber elements, timber components have been very helpful to the masonry structures, and also the timber floors also were connected very well with the help of different these wedge lock, shear locks, etc. And upper floor in residential actually were provided with timber frames at the middle. Openings were smaller in sizes, and most of the public buildings were based on courtyard system, which is a very good system to resist earthquake in both directions, and high plinths, as I have already experienced in many temples, and gradual reduction in wall thickness in upward direction. So these are the peculiarities, so which has been also affecting in the behavior of earthquake resistance. Now, this is very important that there are hundreds of unreinforced masonry buildings in Kathmandu, and these older buildings can be severely damaged during earthquakes and pose one of, if not the greatest seismic threat to the country, and that is reality. That is universal truth in general, but this earthquake damage to unreinforced brick masonries create a multitude of negative consequences for the state, such as injury and death, loss of property, revenue and jobs, and a loss of tourism, etc. Also true. So then the task is what? The realistic risk reduction is necessary, and this is daunting and larger than the available resources below. And that is the question actually has to be addressed during the reconstruction actually, following this 2015 earthquake. And this is one of the most active regions, as I say, in terms of earthquake, and many damaging earthquakes have struck the valley starting from 1255, the first recorded earthquake in Nepal. And very unfortunately, I am repeating again, a building type that is particularly vulnerable to earthquake damage exists in Kathmandu Valley, which is unreinforced brick buildings. We should be very careful. So unreinforced brick building without any limit on the number of stories or the sizes in the plan, etc. So cannot be accepted, cannot be adopted for earthquake resistance. And these buildings can partially or completely collapse during strong shaking, also true, causing deaths, injuries and property damage, and more compounding losses also could follow. So why I am doing say? In the beginning I said the positive parts of these traditional structures, now I am talking about negative. So please try to understand it. That means what? So we have to live up with these masonry structures, also true, but in the meantime our job remains to enhance it, how to make it earthquake resistance. Without that probably we cannot help, we cannot survive and we can go ahead. So like earthquake of 2015, it is not the first time, and that has such earthquake damages has been there, earthquake occurrences have been there. So it was the worst natural disaster to strike Nepal since the last earthquake of 1934, which we call Nepal Bihar earthquake. And so also we know that we don't know when it occurs, like day before yesterday there were quakes, and even there were many rumors and people were panicked, because that was similar to what happened at the beginning of 2015, April 25. Like all the birds were restless. I also actually found it actually, and the dogs were barking, being very restless like that, and people say, look, 2015 is repeating or something like that. That may happen now also, tomorrow also, because this is a random event. We don't know when it occurs, how it occurs, where it occurs. So that's why, like, if we talk about heritage structures of which we are very proud of, so like Kathmandu Valley, we lost 30 monumental structures completely collapsed, and also about 120 historical structures heavily or partially damaged, and so on and so forth. So these are the scenario, and so reconstruction is being taken place with all hue and cry and all this fanfare, but the question is, are they taking place as it should be? Now some of the damages I am showing, like this is one of the, let us say, building in Bhaktapur itself. This is residential building, so this is damaged. Now I just wanted to show that this is also building, but made of reinforced concrete frames actually. So it is not only masonry structures which get damaged, reinforced concrete also got damaged much, like this also reinforced concrete actually. So my purpose is not to show that masonry is better than concrete, that is not my purpose. But if properly designed, masonry structure also could survive if it is 2-story building, 3-story building, 4-story building, and even if it is made in, let us say, reinforced concrete like that, so if not properly designed or not properly constructed, it will not be safe. That is what my purpose is. So I am coming to reconstruction recovery stage. Now this has to be reduced, the damage has to be reduced, and the question actually is where we prepared yesterday, because all the time we talk about that disaster risk mitigation, earthquake risk mitigation, etc. So we give the slogan, that is fine. I am not accusing anybody, I am not criticizing anybody, but we have to think ourselves, where we prepared? Probably not. Are we prepared? After 4 years, Even that is a big question. Let's not ask about will be prepared tomorrow. Whatever it is not late. We have to start with the things what we should do, at least with masonry structures. So make it in enhanced manner the earthquake resistant. Let us retrofit it, let us strengthen it, and we are these days constructing in the name of reconstruction, just distributing some money, but not being, like what our dignitaries said in yesterday inaugural speeches, etc. Also, many things were true actually. It is not taking place as it should be. So that's why the people suffering due to this earthquake are still suffering. 4 years has been passed. What is the progress? So we may probably talk only in terms of the money spent, etc. But all this construction which are reconstructed, etc., are they earthquake safe? That is a big question. And what about those stock of buildings which got no damages at all, which got not assessed whether they were vulnerable or not? What will happen to them when tomorrow the earthquake occurs, which would be of much more larger magnitude and intensity? So that is what we have to think. Now for that also, now these days all these reconstructions are being taken place. So with the initiative of the government or local government or personally, publicly, whatever it is, without detailed assessment. So they don't assess, they are not taking place these things. Although we have been talking about that for a long time, detailed structural assessment is needed, whether they are vulnerable or not, how much they are vulnerable, what are the weak points, and what we have to do. And just assessing the damage is not adequate actually. So damage assessment also depends upon how you do that. And damage assessment, just using the opportunity of this earthquake occurrence, we are just blaming to the earthquake. We don't see now many buildings, many structures are there with all the plants coming out of the walls, etc. And that is not due to earthquake, that is due to lack of maintenance, that is due to aging, that is due to leakage, etc. And we don't give any damn for what is happening. And then earthquake happens to be the coup de grace. At a time everything happens and we just give the bad name to the earthquake and finished. And that is very bad culture we are developing actually. Now even talking about 55 Windows Palace, with due respect to everybody concerned, we did that. I was involved in that, and we finished after many years in 2006. Now the big question is, frankly speaking, how many times this palace has been opened since 2006? Please check it, ask it, and let us dwell upon that. Then even we didn't care what happened after 2015 earthquake. We didn't care after each monsoon season what their leakage or not. We don't. So this is the situation. This is the situation of 55 Window Palace, which is more or less better taken care by the local municipality. So I really should appreciate, not just unnecessary praise. Bhaktapur municipality is one of the rare municipalities or local governments which are very good, which is very good taking care of the local construction, etc., etc. And even in that case, there is such a problem, then forget about other things. So that's why most of the construction, most of the structures which got damaged, at least labeled damage due to earthquake, are due to lack of maintenance, lack of repair, lack of your attention actually. Nothing is being done for 80 years, 90 years. The best example is Kastamandap destruction. Look, Kastamandap actually is the temple which is very famous, by which the name of city came from that temple, Kastamandap, Kathmandu, that is in Sanskrit. Now it is already, now these days it is said that it was built in 7th century or 6th century, something like that. Now recently the Durham University actually carried out the archaeological excavation, and many new things came out actually from there. Now this building, that Kastamandap, which is actually a rest place, frankly speaking, later it was considered as a temple or something like that. Now it did not get any damage during 1934 earthquake, which happens to be a much more larger earthquake than 2015. But in 2015 it completely collapsed. Why? Because nobody was taking care of the leakage, the timber, rotten timbers, etc., and all these deteriorated brickworks, etc., etc. Now it is happening like that. So that also give a good lesson that we must have a very good maintenance management plan, which must be the part of the reconstruction. So it is not just the construct after the damages, so detailed inventory also is very important in that case. What is the condition, and also assessment of the system, structure system, how it is being deteriorated or being, being maintained, etc. So in that way, this is what I just wanted to give some suggestion that condition, damage, and seismic vulnerability has to be assessed completely, and components, load parts, and redundancy has to be established. What are the weaknesses has to be identified, and level of damages has to be assessed, say with the help of available international documents like HAGAS or EMS 90 European microseismic scale 98, etc., and also the causes of damage. Nothing is given, even in the report, large reports, these things are missing, and these are required, like whether it was due to pounding, it was due to, let us say, alteration in materials, or maybe due to poor maintenance, or due to deterioration of materials, or aging, or some environmental degradation, whatever it is, these has to be identified. So it is not being done, and directly, and go for estimating what is the cost and how to award this to the contractor, etc. We do respect, I am saying again, and people don't go give some time in assessing what is the problem. So without assessing the problem, without diagnosing the problem, then people go for, let us say, retrofitting, they call. So retrofitting, that word has been very cheap these days. Everybody is using that word retrofitting without actual meaning understood. So this is not very good practice. So type of intervention, whether it is repair or restoration or rehabilitation or, let us say, reconstruction or retrofitting, whatever it is, that should be defined. That is the type of the intervention only after the damage, after the detailed vulnerability assessment. So following your damage assessment, etc. And also we should be very careful about what are the materials and technology we are using, and what are the principles of conservation, and what is the participation of local community. Look, this is one very important thing. Look, we have been passing through the ages when we didn't have codes, we didn't have engineers, we didn't have architects. So if we did have any, those were only artisans and craftsmen. So they are good, and even we call them as Vishwakarma, that is the god representing the work, etc., something like that. But look at the condition, their conditions. So we are not giving any care of them. As a result, we are having no very good masons, no very good carpenters, no smiths, etc. Remaining all these good people are going outside the country because that is lucrative, and we don't care. The government doesn't give care, and even the training of them is not there. Used to be from generation to generation, learned by mistake. Now even that is missing. So this is really miserable actually in case of this reconstruction, etc. So now these are some factors which we have to consider, like masonry. I like that, I don't like, that doesn't matter, but what is the availability? So what is the culture and tradition? Also what is our living style also has to be taken into consideration. So that's why now, even if given to choice to me, if I want to build a new building, probably I may not make in masonry these days. I may go to better material, not because I am structural engineer, but because available materials. Look at, frankly speaking, I am very sorry to say that the quality of brick is deteriorating day by day in Kathmandu Valley. Used to have our 15 megapascal as the normal compressive strength of bricks. Now these days, if you can find brick with, let's say, compressive strength 5 megapascal, you are very lucky. You can check it. You can check in Kathmandu Valley, but still those bricks are being, sold like hotcakes, and government is not looking at it. And government is claiming that they are reconstructing. What type of bricks they are using for reconstruction? That is the question. Probably that also gives one question to be dwelt upon, that is, maybe we have to go for alternative materials for construction of this masonry. For example, look, we can go for CSEB, stabilized, soil stabilized, compressive, soil stabilized earth block or earth brick. And we have tested in my institute of engineering, we tested. We got 7.8 megapascal for CSCB, which is without any burning, without any expenditure for fuel, etc. This is just your soil block with 5% to 20% your cement stabilized. We get a better bricks, better blocks, better than this burned place. So then that is another alternative material which we have to take care of if it is a new construction. Probably we cannot use that for replacement in the case of your heritage structures, but new construction we can easily do that. Same case with, let's say, hollow concrete block, which may be much more cheaper than these burned clay brick, etc., if that is the condition. Day by day it is deteriorating. 3 megapascal. No, there is one in nearby. This, when you come to the approach, there is one kiln, some Hanuman brick industry or something like that, which produces more than 5 megapascal. That is good, at least that is there. But it charges more money. That is also true. So these are the things which we have to consider, and so that will also lead to the future of masonry structure in Nepal. Now mainly I am just saying that this I have given the reason for the basic damages during that earthquake we observed, but this is equally true what we have to talk about. Maintenance is nil. Lack of maintenance and repair has to be addressed properly now. Like I said, maybe we have to give during this reconstruction. So what is the maintenance management plan? There are almost like void on the public offices which used to deal with maintenance of these public structures actually. Also material deterioration, that has to be tested. We say these days we call about, let us say, your your regular maintenance of these things, these materials and also structures, etc. And so that is checked regularly also. Also isolated alteration of structural elements should not be permitted actually. Like if you look at many structures, like we find all those your wall plates are missing, because masonry actually which are comprised with which were, let us say, talked with the help of, which were improved with the reinforcement of timber, like timber joists, timber frames, vertical and horizontal, as well as this your wall plates, etc. In some of cases wall plates are missing even. So these elements, this isolated alteration has to be considered very extensively. And so this is about the new construction also I am to talk about, because I have talked about much about the old masonry structures. What about new masonry structures? So earthquake resistant design of masonry structures is important, and that can be talked as a combination of tradition, experience and modern engineering principles. Whatever buildings were there, whatever these masonry structures were there, maybe they were not designed properly in engineering fashion. So what? We have to assess it, and our job is to interpret all these non-engineering design with the help of modern engineering knowledges, etc., and to carry out accordingly what should be done to improve it. So two-step procedure is there for even in new construction, that the structure is conceived according to traditional requirements regarding structural configuration, etc. We can establish like that what should be the plan, what should be the elevation, or how many stories, etc. That is fine. But the seismic resistance is verified by calculations, and the dimensions and distribution of structural elements accordingly are modified if required. So also very important structurally, no collapse and damage limitation. So accordingly, no collapse and damage limitation requirements should be fulfilled, like correspondingly the ultimate state which is associated with collapse, and the serviceability limit state which is associated with the occurrence of minimum damage also need to be verified in the case of masonry structures. So this may be the lagging in this masonry structure if we go like that. So lastly, I want to talk about the new dimension in masonry, so which is actually confined masonry. Like this is a picture of a temple actually from Bhaktapur itself. Look, actually it was not made like that. So you see the combination of the tree and the temple actually, right? So they are complementary to each other. So they have become one structure now, and this is the basic principle of confined masonry. That means the masonry structure is being confined with, let us say, that natural tree or timber we can say. So what is this? So these days now people are very very adamant to use masonry structure. Now I have met many people, many friends, many colleagues, and even in some settlements like newer settlements like Bungamati, etc. Every people wanted to have RCC, reinforced concrete frames. They want columns, they want beams made of concrete, no matter how it is designed, and they are very hated. They are hating masonry structure without concrete elements, which was misconception, frankly. And then to that, probably this confined masonry may help to satisfy their, this apprehension, probably. Like, so we are having reinforced concrete frame, and anyway, even if we construct reinforced concrete frame with proper design, etc., we need partition walls, we need infill walls. That probably has been done with masonry, like brick masonry or hollow concrete brick masonry, etc. So now instead of that, if we want to make not concrete frame, so in that case concrete frame is the main principal elements, and the masonry walls, etc., are secondary, which are non-structural. But if we make the masonry itself is the principal, but we can enhance its performance by providing again beam-like things and column-like things. But now we don't call them beam and column, we call column ties and beam ties, and they are basically subjected to only tensile stresses, not bending moment, not shear force, not torsional moment. So this is what comparatively it is shown. First of all, then the wall is made in the case of confined masonry, then only after the, So first of all, wall is made, then after then these frames are made. Not frame actually, that is misnomer I use again. So tie columns and tie beams are used, then its role is to just strengthen and frame this masonry, then we call this as confined masonry, and they should be properly done, So then these are the some features of that I am showing it. So like this again, so slab is fine, it is common to both, whatever it is. So we made first of all frame, that is in reinforced concrete frames, and wall we make later. But in the case of confined masonry, wall first, column beams later. So that may be the answer. Now till now it has been, we have been trying to make the guidelines for Nepalese confined masonry. So now till now Svetlana Brizhev, which is professor at BCIT, British Columbia Institute of Technology, actually she was one of the pioneers in this confined masonry actually. So they have recommended only up to 3-story building. I said we have even made without confining masonry buildings of brickwork up to 5 stories, 6 story equally well. So in that regard, now we are trying many things for Nepal. Like one is, what about stone masonry confined, not brick masonry only. Stone masonry, what about that? And also hollow concrete block masonry is already made. We have made that guideline also. And also CSCB, for example, if we could confine them, these are the some forms which could improve the masonry status with confinement, etc., that we are doing. Now just by the way, recently last month in March, middle of the March, I did have an opportunity to visit IIT Gandhinagar, Indian Institute of Technology Gandhinagar, where whole university has been made in only confined masonry. All guest houses, all academic blocks, all administrative buildings, and all laboratories, everything was made, and that was a very good opportunity for me to look at it, and it was done very efficiently, and they have been able to make it 5 stories building, not 3 story as Svetlana Brizhev wanted. So now that's what I am saying, that the type of intervention has to be done only after proper assessment, damage assessment, and also detailed vulnerability assessment, etc. So in the conclusion, the same thing what I have already said, like the future of masonry structures in developing country is not in a question. It is going to live for a long time again, even though new materials are there, cheaper materials are there, but we probably cannot avoid these masonry structures. Like even in case of Nepal, if we say, so let's say if you go to the remote areas where there is no cement, there is no brick, there is no, even in some places, no sand and aggregate, if anything available, that is only stone masonry, stone. So that means random rubble masonry. At the most probably we can chisel them, we can make them dress stones, and dress stone masonry might be there, but we cannot avoid that. And if we could do that, that is even better. So I just pleaded to one place that, why don't we start that industry that, dressing the stones. If we do like that, two ways we can benefit. One is we can stop the villagers going to, let us say, Gulf or Malaysia or somebody else for lucrative works and coming back with the coffins, etc., and make them work inside the village itself. And it requires not much. So queries are there without any money investment. What we have to do is some instruments like chiseling and all those things, and they are very lucrative actually. So masonry structures has got future still there. In remote areas we cannot avoid stone masonry. Even in urban areas or suburban areas like Bhaktapur or Kathmandu Valley, something like that, probably we cannot forget about the brickworks, brick masonries. But brick has to be improved. Quality has to be maintained. If we want to make them reigning more years in future, then we have to control the qualities. And alternative materials also, as I said earlier, CSCB or hollow concrete block, etc., as the replacement of brick also has to be thought of, because slowly there is a growing trending of going for green materials without emission of carbon, without energy dissipation, energy expenditure, etc. So in that way, probably brick has got not very good future. That too is charged with, let us say, child labor or something like that. Now, possible improvement may be confined masonry. Earthquake resistant enhancement is necessary, like providing ties in horizontal and vertical direction, and also properly connecting the timber floors, or let us say even if it is RCC floor, even better, like that for the new construction. Most important is quality control. So it is not tolerable that, so there used to be standard, government owned standards are there, nobody is taking care of that. So even I pleaded in one gathering with our members of parliament that why don't you stop all those kills? I flatly said that, and there was no answer. And very sad that our political generals are doing nothing on that. And there is a charge that Bhaktapur is full of all these kilns, etc. And that is not true actually. In last workshop also I told that this is not true, that one of my colleagues actually said that, so it is mostly made in Bhaktapur. It is not true, but Bhaktapur is lucrative for those manufacturers of bricks because plenty of lands are there in cheaper rates, and child labor, etc., is very much available. That's why now and then, left and right, if you look, we see only the kilns which are producing bricks, that too of not quality. So we have to stop them, in my opinion. Now, repair and maintenance management plan should be the intrinsic part of this component of reconstruction plan, and artisans and craftsmen has to be, protected actually. Training has to be given now. We need more artisans, more craftsmen like masons, carpenters, stonesmith, and all those things are required, and we must have that. Now, lastly, I want to propose one thing, that just using the good nature and let us say the trust on the Nagarpalika, Bhaktapur municipality, and just using this college, Khopa Engineering College or College of Engineering is being run under the aegis of this municipality, we do have a very good opportunity. And Bhaktapur is not a large town. We do have plenty of, as I said, plenty of masonry structures. Let us start doing the census of that. Let us improve the data on these things, and let us also start assessing what is the vulnerability of these individual buildings. And it may take some years, no matter, but at least we will have some data and plan to make it resilient to the future earthquakes. We can do that with the help of these colleges, with the help of municipality, and probably this would be the example for Nepal, because many things have been done through this municipality, which has an exemplary and has been repeated by the others. Same, let it happen again. So with these few words, I want to conclude my speech. Thank you very much.
Thank you, Professor Dr. Maske, for your provocating address on masonry structures in the post-earthquake reconstruction. Now, as per our schedule, we have 15 minutes refreshment break. After the break, we will have parallel sessions at dedicated 3 halls. Therefore, I would like to request all the presenters to be in respective halls. And dear participants, please make sure that you won't miss the papers you are interested in. Ladies and gentlemen, a friendly reminder that we will have keynote address by Professor Dr. Susumo Kono after lunch in this hall 1. Now let us break for tea and assemble back for session in dedicated halls. Thank you.